Welcome to the session on exponentials and logarithms, exponential modelling. The objectives for this session are to use and interpret models which use exponential functions. We begin by looking at exponential growth and decay. The exponential function e to the power x can be used to model real-life situations where the rate of increase is proportional, for example, to population size at a given time. Here's a sketch of exponential growth, y equals a times e to the power kt, where k is greater than 0. A is the initial value at time t equals 0, as shown here. We begin with a slow increase and then a rapid increase. Likewise, the exponential function e to the minus x can be used to model the rate of decay. Here's a sketch of the graph of y equals a times e to the minus kt, where k is greater than 0. This denotes exponential decay. The initial value is at a, at t equals 0. We begin with rapid decrease and then a slow decrease. Do note that k is greater than 0, so plus or minus shows growth and decay respectively. A is the starting value at t equals 0, and t is used for time. So to summarize, exponential growth is modelled by y equals a times e to the power kt. And exponential decay is modelled by y equals a times e to the minus kt for constants a and k, where k is greater than 0, and variable time t, which is greater than or equal to 0. For all real values of x and any constant c, remember that if y equals e to the power cx, then dy dx equals c times e to the power cx. We will now have a go at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. The following formula models the population of a village. P is equal to 12 plus 7 times e to the power t over 25, where P is the population in thousands and t is the time in years after the year 2020. Calculate the size of the population in 2020. So let's solve this. In 2020, t is equal to 0. Therefore, we input t equals 0 into the formula for P, and therefore P is equal to 12 plus 7 times e to the power 0. Here we've input t equal to 0. And tidying up gives us that P is equal to 19. And therefore the population is 19,000 in 2020. And now for example 1b. Using the model, predict the population in 2045. So let's solve this. Since the year 2020 represents t equals 0, in 2045 t is equal to 25. Therefore, we input this value into the equation for P. So we have P is equal to 12 plus 7 times e to the power 25 over 25. Here we've input t equal to 25. And this gives us 12 plus 7 times e to the power 1, which is equal to 31.028 to 3 decimal places. Therefore, the population is 31,208 in 2045. And now for example 1c. Find dp dt and interpret the significance of your answer. So let's solve this. Now p is equal to 12 plus 7 times e to the power t over 25. Therefore, if we differentiate this, we obtain dp dt equals 7 over 25 times e to the power t over 25. Since k is greater than 0, the population is exponentially increasing. And now for part D. Sketch the graph of p against t from 2020 to 2070. So let's solve this. In 2020, t is equal to 0 and p is equal to 19. So the graph will look something like this, where the y-intercept is at 19. And now for example 1e. Explain whether you think this model would be valid when predicting the population in the year 3000. Let's solve this. In the year 3000, if we were to use the formula, t is going to equal 3000 minus 2020, which equals 80. And therefore p equals 12 plus 7 times e to the power 80 over 25. We have input t equal to 80 into our equation for p. And calculating this gives us 301.390. This implies that the population is 301,390 in the year 3000. However, the model is not going to be necessarily valid for predictions that far into the future, because we do not know if the current trends will continue. This brings us to the end of this session. If you have understood its contents, you should be able to use and interpret models which use exponential functions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.